Thank you. And thank you all for showing up. As Ove says, I now have the opportunity to first present the thesis, the overview, and the topic area, and the 10 papers that make up this thesis. But first off, thank you all of you for showing up. Thank you to the assessors for having put in so much time and effort to sort of go over the work that I'm going to present. There's so many of you. And actually also, I think there's about 30 or so via the webcam positioned up here. So I now have to give an opening statement and presentation. And the starting point for any such presentation, I guess, should be what I'm doing and why. And around the time I started drafting this thesis, I read through this book recommended to me by a colleague, A Biography of Cancer. And somewhere in the middle of that, not standing out in particular, but somewhere in the middle, there's this quote that quite clearly said to me what I'm doing. And I thought I'd start us off with that. So this says, we humans are chemical apes. Having discovered the capacity to extract, purify, and react molecules to produce new and wondrous molecules, we have begun to spin a new chemical universe around ourselves. Our bodies, our cells, our genes are thus being immersed and re-immersed in a changing flux of molecules. Pesticides, pharmaceutical drugs, plastics, cosmetics, estrogens, food products, hormones, even novel forms of physical impulses, radiation or magnetism. Some of these inevitably will be carcinogenic. We cannot wish this world away. Our task then is to sift through it vigilantly to discriminate bona fide carcinogens from innocent and useful bystanders. And basically, this is what I'm doing. I'm sifting through pharmaceutical drugs to identify stuff that pose a threat or problem and discern it from useful drugs or useful bystanders. So what is the potential outcome of such a sifting through process? Well, either we detect an increased risk. So we might stop using the drug in select high-risk populations, or use the drug but monitor the users. We might also detect a decreased risk. So we might give the drug to high-risk populations, or more realistically, we might know more of this cancer via this mechanism to develop new drugs and new treatments. For the vast majority of studies, however, it's a matter of detecting nothing. See no association, and that is back to the quote, this is then an innocent and useful bystander. We can use the drug without being overly concerned of a carcinogenic property. This is not a theoretical concern. There's plenty of drugs that might pose such capacity. For instance, the antineoplastic drugs, chemotherapy, or immunosuppressants. Also hormone therapy. This is really complicated. This might either give you cancer or protect against cancer, depending on what, if, and how, and when, for how long you use it. And there's a few other drugs, but very few other drugs. It's mainly a matter of these three categories. The list of drugs where there might be a cancer risk, however, is very long. This is a list of drugs that are suspected of. They are possibly or probably carcinogenic, but we don't really have the data to finally classify them as carcinogenic drugs. And that leads to the question, of course, don't we know the side effects of drugs used? And basically we do, but for cancer in particular, we might have a problem. So before the drug enters the market, there is some assays testing for carcinogenic properties. But mainly for human data, we rely on the randomized controlled trial. And such a trial, getting the drug to the market, might encompass thousands of patients followed for even years. But that is way too little and way too short to detect an increased risk of cancer, at least if it is a specific and not that common cancer. So before it's marketed, we have insufficient data. When it is marketed, we mainly rely on the spontaneous reporting systems. But for that to detect a cancer risk, it's a matter of a physician saying, well, my patient got that cancer, maybe it's related to that drug he used 10 years ago, and file a report on that, which is obviously never going to happen, or at least not sufficient amount for us to get a signal and look into it in more detail. So we are at a peculiar place with this particular type of side effect. So this is where pharmacoepi, the study type that we are doing, enters the field. So this is the study of drugs on a population level. And in Denmark, we are in a very fortunate position to carry out pharmacoepi studies, since we have very strong health registries and other registries going back for a very long time. And just as important, we have the CPR number so that we can link everything together in an unambiguous way. In this thesis, the work that I present here, we mainly rely on the Danish Cancer Registry going back from 43, the prescription database containing all field prescriptions since 95 at Danish community pharmacy. Also, we use data from the patient registries, some education registries, and a few others. We've used these over and over again for a lot of different things, but in terms of cancer, we have over the last nearly a decade, I've been involved in these 41 different projects. And this span a lot of different areas of questions, but all these 41 are within the space of cancer. And they can be grouped in quite many different ways. For instance, these three revolve around cancer risk in the patient with a very rare neurological disorder, myasthenia. Or these three were because the authorities in one way or another told us to do something or look into something. These 6 are matters of hydrochlorothiazide and skin cancer, which constitutes an increasing part of what we do. These 8 revolve around methods work, developing new methods and screening for signals. And in that group, I guess this should be highlighted. This is a review paper where we outlined what we think is sort of best practice within the types of study that I'm going to present. This is actually the first version of my thesis, but upon realizing this has turned way too methodological and not at all providing any form of overview, I rewrote it, submitted it as a paper, and started a new thesis instead. So back to these 41, luckily we don't have to go over them all. We have the 10 papers here. I've selected them for different reasons. Mainly they share a common sort of denominator in terms of methodology and tell a coherent study, I think. So these are the 10 papers of the thesis. We can group them a little. We have the 6 papers first here. These 6 papers constitute single hypotheses that we then address. So this drug might cause that cancer, and we then follow up on that hypothesis. Growing a little wary of running back and forth between new hypotheses from the literature, we decided to grow our own hypothesis. In this paper, screening for new associations, and the last 3 studies comprise reassessment of a signal from the screening exercise looking at hydrochlorothiazide and skin cancer, different types of skin cancer. So from here, I guess it's a matter of buckle up, because I have 10 studies that I'm going to present and give you an overview over. So I'm, of course, going to go through them one by one. So the first study is entitled Use of Benzodiazepines or benzodiazepine-related drugs and Risk of Cancer, that is, any cancer. And as is often the case, the starting point is another study. This study claimed to have proven an increased risk of cancer. Actually, they also looked at mortality, saying that users of these hypnotics die off in a 4- to 5-fold faster pace than those not using it. But they also claimed a 35% increased risk of cancer, which is the claim that we wanted to reassess. So when such a paper comes out, of course, we scrutinize it. What did they do? And in this particular case, we ended up writing a letter to the editor arguing that there are substantial bias to the study design and analysis. So I don't think we at all can trust the conclusions reached by that paper. However, nobody reads this, so it's a fairly sort of amount of time wasted, at least if we really think that this is a problem. So we sat around, me, Morten, Søren, and Jesper, discussing, so what should we do from here on? And as Uncle Ben says to Spider-Man, once you are in a position of great power, be that perhaps statistical power, leveraging the Danish registries, you have a certain responsibility to use those registries to make things right when they are wrong. So we are in a very fortunate position, leveraging Danish data, much better position than anyone elsewhere, to assess such an hypothesis and come with a stronger analysis, show what is up and down in such a. So we thought, well, we need to reassess this ourselves. So what we do, and what we've done throughout all the 10 studies, is doing a case control study. And I'm going to spend a little more time for the first one to outline the underlying methods and methodology. So what we do is we identify a group of cases. This is any cancer, so we had 150,000 of them. These are patients with a cancer. And for each of them, we find 8 controls. So we also have a very large group of patients without cancer. They are of the same sex and of the same age, but other than that, they are unrelated. One group is sick, one is not. Within these 2 groups, we discern how many use these drugs. So among the cancer cases, 1.7% were long-term users of hypnotics. This corresponding value was 1.5% in the controls. And the underlying thinking is that this is heavily skewed if those with the disease tend to be users of the drug, whereas those without the disease don't. It seems like the drug might be associated to the disease in question, in this case cancer. So we test that using a statistical model, and that basically does, what that does is that compares use to non-use and how that predicts being sick. So it's a matter of saying how much does this particular drug exposure increase your risk of cancer or decrease the risk. Before going into the model, we also map out a lot of other things. For instance, subcategories of use. This is subgroups of benzodiazepines and their comorbidity, use of other drugs and diagnosis. We might do education, income, or other markers so that we can adjust for this in our analysis. So what we hope to get out of it is a direct estimate of the cancer risk carried by the drug use and nothing else in the ideal situation. So once we put that into a model, we get an estimate. And that is by a statistical model, but we end up with something of a relative risk. So a relative risk of 1.09 corresponds to an increased risk of 9%. So in this study, we estimate that long-term use of hypnotic carries a 9% increased relative risk of getting a cancer. There's also some statistical uncertainty to that. So we have a confidence interval outlining it's probably 9% or somewhere between 4 and 14. This is the overall estimate comparing the use of long-term versus non-use on the overall risk of getting any cancer. We do a lot of sub-analysis as well. For instance, here we looked at different categories of use, length of exposure or intensity of use during that time. And overall, we see very, very small association. There might be a slight trend towards an increased risk, but it's very close to the norm. So overall, from such a study, we conclude that we see no association between use of benzodiazepines and cancer risk, except for what is likely explained by residual confounding. This latter part probably needs to be substantiated a bit, because we do see an increased risk, and Danish, the author of the other one, quickly pronounced, oh, well, they did this and also found what I claimed to see. But we think it's a matter of residual confounding, because we adjust for a lot of things, but there's a lot of things we cannot adjust for. And for instance, it's likely that users of these drugs smoke more, and this risk is actually specific to smoking-related cancers. So that's probably it. So residual effect is probably something that might go away could we adjust for smoking. We have actually quantified this later in a subsequent publication using survey data, seeing that a higher proportion of those users were smokers, surprisingly non-drinkers, and had a sedentary lifestyle. So we have sort of quantified this. And this is also a slight dose-dependent association, so long-term users smoked even more than short-term users that smoked more than non-users, which might explain the slight gradient. So basically, we think this is probably the explanation as we hypothesized. The hypothesis overall is far from dead, however, because Daniel Kripke runs the webpage darksideofsleepingpills.com and keeps on his sort of giving presentations and writing books on the fact that this type of drug causes cancer. And by the time of this presentation, his paper is cited 350 times and downloaded 24,000 times, whereas our rebuttal is sadly that's roughly 10 times more than our study. So the hypothesis is regrettably far from it. So second study, so now we're speeding up a bit. Statins and risk of renal cell carcinoma. Here the hypothesis comes from the lab. Somebody poured statins, that is cholesterol-lowering drugs, onto different cancer cells and noted that they seem to inhibit cancer cell growth. In particular, in renal cell cancer, one epidemiological study, a few epidemiological studies, looked into this association and noted that it seemed like statin use were associated with a decreased risk of renal cell cancer. So in this particular study, they did see a lower risk. That risk was only seen in women, and no dose response pattern. So it's not the strongest piece of evidence, but it definitely created a lot of hype on this hypothesis. And please remember, specifically for women, because that's important in a little while. So such a study is really complicated because there's something called confounding by indication. Users of statins are not comparable directly to non-users of statins because they have a sedentary lifestyle of smoke and thereby got heart disease and thereby getting the cholesterol-lowering drug. So it's not a very easy direct comparison to do. So we knew this going in. We identified a group of renal cell cancers and mapped them out by long-term use or cumulative duration of use, and then we did this estimation. In the first version, we simply adjusted for the sex and age, and here we see a roughly 50% increased risk of these cancers, which is directly the opposite of our hypothesis. Upon adjusting for everything we could think of, a lot of different factors, we got this down to a fairly clear no significant association. Slightly increased risk, but probably not much going on here. So we ended up concluding that this is probably overall a null finding. In subgroup analysis, we did see a slightly increased risk specific to women, which goes very much against our initial hypothesis. Might be a chance finding, but it is a little odd that's an increased risk specific to women. So beyond this particular finding, this all yielded neutral associations, and we ended up concluding this is probably not a thing. This drug doesn't protect against this cancer, sadly. It was very hyped, so we got it into a very large, actually the largest urological journal, European Urology, and they said, okay, fair enough, thank you, and we'll also give you an editorial, so we really highlight your study. We're really happy about that until we saw the editorial entitled Trouble in Paradise, Unmeasured Confounding in Studies of Etiological Factors, where Jennifer Ryder ended up concluding, in the end, this large study does not bring us any closer to answering the point. All right then. I really don't agree with her, but that's another matter. I think this nicely highlights the fact that when such an hypothesis is hyped, it takes a lot to quench it. So I'm fairly certain in the same study, had we seen a protective effect, you would go, that's what I said all along, and not question our findings. This is very much still hyped, not only in terms of cancer prevention, but also in terms of cancer prognosis. There's several trials, actually randomized controlled trials ongoing, whether giving statins to cancer patients prolong their life or giving a better prognosis. I am very skeptical, but I of course hope to be proven wrong. So for the third study, use of lithium and renal and upper urinary tract cancers, you have probably guessed it. Another paper, this time a French group, said they had done a cohort study or some sort of study saying that there is a seemingly increased risk of renal cancers with use of lithium. The study is a little peculiar, but what they do report is they follow a fairly small cohort and note 14 renal cell cancers, or 7 cancers and 7 benign lesions. And from that, they estimate that this is more than they would expect, roughly 10-fold more. It's a very crude estimation, but it seems like there might be an increased risk of roughly 10-fold increased risk. Going into the literature, we identified a nearly identical paper by Wolfmark and colleague. Also, same thing for the small cohort, 6 of the patients got a total of 7 cancer, which is an oddly large number. So thinking of lithium, this might actually make a world of sense because this is transported by the kidneys. We know that long-term use damages the kidneys, either direct, so it's a lower kidney function, and we also know that a very large proportion of long-term users of these drugs have microcysts, which might be sort of an early stage cancer or very early stage cancer. Somewhere between 50 and 100% of all patients have this. So the biological hypothesis makes sense. So we did the same thing, got 6,500 renal cell cancers. Only 14 of them had used lithium for more than 5 years. So already there, this is probably not a major crisis, so to say. We estimated a 30% increased risk, but from the confidence interval, you see that this is basically also compatible with a null finding. This is probably nothing. The dose response pattern had a slight increase, but it's sort of a nonsensical one since it crosses unity, goes from protected to an increased risk, and very small number of patients, very wide confidence intervals. So overall, we interpret this as a null finding. So if we then should question this, one could argue whether saying, well, it might be a null finding is really sensical when it's a safety question. What we're really interested in discussing is whether we can exclude the larger effect up here. So from this, when assessing this sort of finding, we need to consider what potential biases might be left, and one bias is smoking. Lithium is used for bipolar patients or patients with bipolar disorder. We know that patients with bipolar disorder smoke a lot more and more intensely than patients without this disorder, and smoking is a risk factor for this particular cancer, so whatever we do, we would expect to see a slightly increased risk. If we go from this and say, well, this is probably the truth, this corresponds to 1 extra case of cancer per 12,000 years spent as a long-term user. So not a major absolute risk. And the sort of worst case scenario going from this is a matter of 1 extra case per 3,000 years spent as a high user. So again, on an absolute scale, this is not a major issue. And that's our conclusion. We exclude any major effect of long-term lithium on these cancers. Funnily enough, another Danish group using the same data but analyzing it independently and in a different analytical design got to the exact same conclusion. They were a little pissed we published our findings 1 month before they did, but other than that, we got to the same conclusion. Fourth paper is sort of a spin-off of the third one, use of lithium and colorectal adenocarcinoma, because once we got that done, we have this ion channel, and this ion channel is responsible for accumulating lithium in the kidneys. So that's sort of part of the biological hypothesis in the previous study. And Boy said, well, you do know, Boy, that's one of our co-authors, this particular ion channel is actually also present in colorectal tissue. So there might be something here we needed to take a closer look at. So we did this, and colorectal cancers are much more common cancers, so we have a very much better sort of outset of data to go about this hypothesis. 78 long-term uses, and slightly increased risk, but overall definitely compatible with that null finding as well. Duration of use, very long-term use, 10 years or more, slightly increased risk, but still fairly low numbers. The only sort of outlier in this study was the topography. So specifically for colorectal cancer of the distal colon, we found an increased 50% increased risk, and this is actually statistically significant. And I made very little of this until I talked to Boy, and he said, well, this ion channel actually might show a gradient, so there's more of it in the distal colon than in the proximal colon. At least that's what we think looking at data from rodents. So we don't really know it in humans. All right, then, so what about rectum then? Rectal cancers, they should then show an even stronger association, or what? Yes, based on rodent data, that should be it, and it really didn't. So that's probably not it. But there's something here we don't fully understand that might be worth looking into. Or maybe it's a fluke, but I don't think it's like it. There's probably something here. For the fifth paper, tricyclic use, tricyclic antidepressants and risk of glioma. Again, another study, but this time it's a little sort of the opposite pattern. They didn't claim an increased risk, they claimed a protective effect. From the lab, they had seen that, not their group, but others had shown that putting tricyclics onto glioma cell lines protected against glioma formation. So this is a particular scenario where they hypothesized this. They looked at, I think, 8 or 10 cancers, and specifically for gliomas, as they hypothesized, saw a protective effect, and almost 40% reduced risk, and a fairly narrow confidence interval. So something seemed to be going on specifically for gliomas. The question then begs is, should we go into this? We have a slightly smaller data set than they had, or at least we had lower use of tricyclics. So going in, we knew that this would definitely not be a definite answer. We could not come up with a this is right or wrong. So should we really waste time and effort on this, knowing that a priori? But this is a peculiar situation because glioma survival is horrible. At least glioblastoma, which is high grade or grade 4 gliomas, there's a median survival of 14 months. The vast majority of it within 5 years, and we have absolutely no improvement in the handling of this disorder. So whatever we can come up with of new potential signals or questions that might need to be addressed is actually worthwhile here. So we knew going in we could not provide a definite answer, but we hope to make available a Danish estimate to go into, for instance, later meta-analysis. And what we got was that we saw a slightly reduced risk with ever use, a roughly 30% decreased risk with long-term use, somewhat of a dose response, although the last graph is outlying as an outlier. So this is indicative, I might say. It does seem like something is going on. And to strengthen the interpretation of this, we did a negative control using SSRIs. It's another antidepressant, and here we found more or less nothingness across the board. So that does sort of strengthen our interpretation that there's something going on, but from the confidence intervals, definitely this might also be a null finding. Sure, that might be. So this is something put forward for later studies to sort of look across studies to conclude. When we did the study, we had cases up until 2012, but now actually we have data for an additional 3 more years. So I thought, well, I'm going to give this presentation, so we should probably revisit it. So we went back and reanalyzed everything. And now we have a statistically significant effect, but specifically for current use, the long-term estimate is attenuated somewhat. It's still indicative protective effect, but it's definitely attenuated. So, well, an updated estimate, we might publish this as a letter or something, making it available. Annoyingly, however, the negative control of SSRIs now also shows some sort of protective effect, and I really don't know what to make of that. The hypothesis is far from dead. The new paper in Frontiers in Pharmacology talking about drug repositioning in glioblastoma have actually highlighted this hypothesis. And they, by the way, also highlight there might be something going on with SSRIs as well. So this is this is an overused sentiment, but we really need to do further studies on this. For the 6th paper, sildenafil, Viagra, and other Viagra-like drugs and risk of melanoma. Again, a high impact paper claimed there's an association. It's a fairly small study, but it seems like there's a twofold increased risk of melanoma with use of Viagra. It seems like an odd hypothesis, but actually it makes a world of sense from a pharmacology point of view, because downstream effects of phosphodiesterase inhibitors actually does mimic some of the steps that a cell undergoes into turning into a melanoma. So there is actually more sense to it than you'd think. This, of course, created quite the stir in certain demographics, not only in Denmark, but also all over the world. And thinking that this is an international issue, we went to our colleagues in Kaiser Permanente, an insurance scheme in the US, with a very strong research division, with a history of long tradition in drug cancer studies. Actually, Gary Friedman, starting that group, started doing this 4 years before I was born in 82. So we contacted them and said, let's do 2 parallel studies here. So for the Danish study, we did find a slightly increased risk, borderline significant, and there's some suggestion of a dose response in the sense that the 2 final sprays here showed a slightly increased risk. In an absolute scale, this is close to nothingness. For the Kaiser Permanente study, the US study, we saw absolutely nothing across the board. So overall, this doesn't seem to be a major issue at least, and nothing near the twofold increased risk, because these sprays were not present in the initial analysis. They were talking ever use. So this is definitely not compatible with their finding. We also looked at the staging of the cancer, and we saw that there's an increased risk in Denmark specifically for localized cancers, whereas more advanced disease was a protective effect. This is somewhat compatible with our notion that Viagra users tend to go to the physician more. They have a lower threshold for getting their diagnosis. So they might more readily get the localized diagnosis, but they are then in turn protected from the severe disease. This is, of course, much more prevalent in this one. And we see the same pattern in the US data. In situ carcinomas or in situ melanomas, slightly increased risk, nothing on localized, and a protective effect against advanced disease. So we put forth the hypothesis this is probably due to healthcare adherence. They go to see the physician more and therefore get the diagnosis compared to non-users. We were not the first to publish on this. Regrettably, Stacy Lööf published in JAMA, first on a Swedish data set, markedly lower power than what we had, but overall reached the same conclusion. And just before we published ours, 2 other papers from Matthews and colleagues and Leon and colleagues using UK data published. And wondrous thing about this particular study is that all 4 of us, all 4 papers reached the exact same conclusion. There's a slightly elevated risk. It's probably not causal. It's due to healthcare adherence. And the 2 UK papers all said, and it might also be a matter of sun exposure. Users of Viagra might, in general, have a slightly higher sun exposure. So we have explanations for it. This was neatly summarized by Stacy in the meta-analysis in the JNCI afterwards. So the 7th study. So some of you look a little like this now, and I did as well around the time I got to this. So we cannot keep doing this running back and forth, quenching, or sometimes successfully, sometimes unsuccessfully, trying to quench this hypothesis or the other. So we need to do something else. And at the time I was a PhD student thinking of this, and I think I need to try doing something else. So I drafted up this program. This is the first part of a very long statistical analysis. And this is intended originally as a joke, as a trick I want to play on Jesper, my at the time PhD supervisor. I should probably not try to argue why this is funny, so I'll skip that part. Nevertheless, I ended up doing a program that I called RAIST. So RAIST is an acronym, something also we sort of take great pride in doing, acronyms that is, and this stands for Rapid Assessment of Carcinogenic Effects of Drugs. So the joke part was that I, one morning, had completed this program, went to Jesper and said, should we do another study? He said, yes, what about this hypothesis? That was around 8 in the morning. Around 12 the same day, I said, here's the analysis. I provided a full deck of results because I created a program that had pre-analyzed everything, had everything ready, so to say. So I simply had to put in what drug is now under scrutiny and what type of cancer are we looking at. The acronym RAIST is, of course, reminding me that's deliberately raised to remind me that this is a hasty analysis. It's not a refined analysis in any way. So, okay, having played around with that sort of for a bit, and this is probably onto something here. So we applied for funding and got a larger grant to develop a screening tool for carcinogenic effect of prescription drugs. And what we did in short was that we looked at nearly 300,000 incident cancer cases. We divided them into 99 different cancer types. For each of these cancer types, we identify what drugs are fairly commonly used and we tested overall 22,000 drug cancer pairs. So on average, 200 some hypotheses per cancer type. We looked at long-term use versus non-use, and long-term being having filled more than 8 prescriptions. So that's roughly 2 years of chronic use of a drug or 8 courses of antibiotics, for instance. And had a sort of an algorithm to define what was an initial signal. So from the 22,000 tests, we had 4,500 potential signals coming out of it. Saying, okay, 4,500 of this, there's something slightly skewed we need to look into. From the 4,500, we killed off 3 quarters as there were no evidence of a dose response pattern. Then I had this idea for another test, but that clearly failed, and we ended up with 1,000 signals. So we had 1,000 potential signals, 2/3 indicative of a carcinogenic effect and 1/3 indicative of a chemopreventive effect. So we published these 1,000 signals in full. So 6 large spreadsheets outlining this drug might be associated to this cancer to this degree. And in this, there's a lot of nonsense, not a lot of noise. The noise part comes from very, very small number of cases because we had a cutoff of expecting or seeing 10 exposed cases. And this is too little to provide solid estimates. So generally, this should probably have been increased, but it was an a priori decision. Another issue here is a lot of nonsensical associations. For instance, drugs used against chronic obstructive pulmonary disease, smokers' lungs, are strongly associated with lung cancer, which is fairly obvious why that is, but probably not a causal thing on pharmacology. So there's a lot of issues with this list, but it does create a repository for future studies. So we highlight this list, for instance, going to conferences. This is a copy of a conference poster I brought to a conference once, saying we have a list of 1,000 potential drug cancer associations and showing a QR code and a direct link, so you can go directly to that link. It still works, by the way, to see the 1,000 signals and have a look for yourself. One signal that we noted, one of the strongest one, was that of a combination of use of hydrochlorothiazide and amiloride associated with squamous cell carcinoma of the lip with a roughly 7-fold increased risk. So this is clearly an outline, an overall pool of associations. And one of the studies we look into, once we look into the literature, it was quite clear this is not a matter of amiloride, it's a matter of hydrochlorothiazide, this compound. And I'll get back to this in the last 3 studies. We also had a few other interesting signal stuff that we're working on now, but in the interest of time, I've skipped them for now, but I have them if you want to discuss them later. So for now, what we're doing is that we are trying to set up a similar program in Norway. So we have another list of Norwegian signals so that we might prioritize by taking what is apparent on in both cohorts. We're actually also trying to redo the Danish signal. We are a lot wiser now than we were back then, so we can do it a lot better now, I think. So we are trying to push this forward, definitely. But importantly, I think it's important to emphasize the finding that overall, we found a few signals, but overall, it doesn't seem like there's association between drugs and cancer, left and right, that we simply haven't noticed. And that is, after all, a nice finding as well. So for the 8th study, we revisited this particular signal, doing it in a much more tailored and refined analysis, not an independent analysis of such, but a refined analysis of hydrochlorothiazide use, building to it though by also taking hydrochlorothiazide from other combinations and trying to look at only other combinations than the amiloride combination. So basically what we found is long use or high use of this drug was associated with a 4-fold increased risk. And in dose response analysis, we found a very striking dose response pattern that once you get past roughly 50,000 milligrams, your risk increases quite dramatically, up to an 8-fold increased risk in the highest strata. So basically we confirmed that, and also when excluding use of amiloride, we found a similar pattern, although the last part here went away since the very long-term users tend to be amiloride users. So for the 9th paper, we thought, well, if that's the case for squamous cell carcinoma of the lips, which is sun exposed, and the mechanism is that this might increase your sensitivity to sun exposure or UV damage, well, then we might also see something on skin cancers and non-melanoma skin cancers in general. So we hypothesized we should look into basal cell carcinoma and squamous cell carcinoma outside the lips. And basically what we found was what we hypothesized, a clear but weak association to basal cell carcinoma increasing up to roughly 1.5 times baseline risk. But for squamous cell carcinoma, this increases roughly linearly, at least now that I've fixed the y-axis as instructed. And you see sort of up towards of a 7-fold increased risk with the highest exposure strata. So there's definitely something on it. This is of course also skin underneath clothing, etc. So I probably expect this to be a less sort of direct association than the lips, but it's basically the same thing. This might of course be a matter of confounding by the underlying disease, so we need to check whether other antihypertensives showed the same association, and luckily it did not. So this is other types of antihypertensives. Also the very closely related benthal fumifyoside showed absolutely nothing in terms of basal cell carcinoma and nothing in terms of squamous cell carcinoma. So this is a specific effect for hydrochlorothiazide, which of course builds to our interpretation that this is probably a causal thing. For the final paper, we looked at melanomas. Melanomas being another type of skin cancer potentially associated with UV damage. So overall, we found no clear association, a slightly increased risk, but in absolute terms, very small. Absolutely nothing in terms of dose response. It does increase, but it doesn't start in unity, so it doesn't seem like there's something going on. When stratifying by type of melanoma, the superficial spreading melanoma, the most common type of melanoma, showed absolutely nothingness throughout. The nodular melanomas, the most dangerous melanomas, showed a fairly clear association with a 2-fold increased risk and a fairly clear dose response pattern with increasing use and also statistically significant. And then finally we had the lentigo melanomas, which did see an increased risk, but an odd sense of the sort of the dose response pattern jumps up and down here. And this, I know, having looked at this, is because some of the cases is very close to the gap here. Because in the earliest analysis, it was more sort of clear, but this is what we planned a priori, so this is what we report. So summing up across these 3 final studies, hydrochlorothiazide overall, hydrochlorothiazide is actually positioned somewhere here on the list that I showed you to begin with. This is a drug that is suspected of causing an increased risk of cancer, mainly because of a study by the Kaiser Permanente guys back in 2012 or 13 on lip cancer as well. So, and the understanding that this is UV sensitizing. So this is now probably going to be reclassified based on the data we've provided. The authorities have also taken a look at these data and have ended up in conclusion that this is probably causal, at least for basal cell and squamous cell carcinoma. The melanoma findings is still sort of unresolved, which I think is definitely true. So once the authority says this is probably something, we then get updates to package inserts, leaflets, and informations to patients, and send dear doctor letters to all healthcare professionals saying this is now a thing, you need to consider this and that, and here's what you tell patients and how to act on it. In Denmark, this is unpublished results, but we recently finalized this has led to a roughly 25% decrease in the use of hydrochlorothiazide overall. This is the 4 studies or 3 studies and the dear doctor letters going out. So, and it has gotten some media attention, probably why it already diminishes before this point in time. So roughly 25% decrease. This is of course potentially a good thing, it's also potentially a horrible thing. So, and it's difficult to assess, of course, directly. But for the next slide, I apologize, it's a little busy. I tried to do the same thing, but splitting people into whether they had a history of skin cancer or not. So the black lines are those with a skin cancer, and this is 3 different age groups. So the youngest patients with a history of skin cancer now only use roughly 25% of that amount of hydrochlorothiazide, whereas the older ones with skin cancer is down to 60%, and the oldest without a skin cancer is roughly at 85%. So at least at a population level, it seems like the patients that should probably not use hydrochlorothiazide are, at least to the greatest extent, stopping their use of hydrochlorothiazide. So I think this is somewhat reassuring in terms of whether this is relevant. For us now, it's mainly a matter of replication. We are now in contact with quite a lot of researchers all over the world in terms of looking at this association. One of the more peculiar collaborations is with Dr. Armand Cognetta, a US Mohs surgeon. He has basically reached the same conclusion that we have leveraging big data by cutting off squamous cell carcinomas 1 patient at a time and wondering why they all used hydrochlorothiazide. So he has basically reached the same conclusion from a clinical point of view. And published this a Mohs surgeon concern letter saying, I have these group of patients, they sprout squamous cell carcinomas left and right. It's odd they all use hydrochlorothiazide. I talked to him and said, like, giving this presentation, and said, well, you should probably get this picture from me then. This is one of his patients. This is from April. He says he's continuing to see patients coming in with multiple squamous cell carcinoma lesions. This patient has 3 different squamous cell carcinomas and is a long-term user of hydrochlorothiazide and have, by the way, consented to have image shared and all that. And this illustrates quite nicely that this is not only basal cell carcinoma. This is a problematic cancer in the sense that it's not very rare, at least, to metastasize and kill you off, but removing cancers like this leaves a lot of scar tissue, and it's a very big problem for the patients. So replication activity is ongoing in Holland, Taiwan, Spain, US, UK, and we are struggling to set stuff up in Australia. Already got the results from Taiwan, and Spain is also on the way. And generally, it seems like we are definitely seeing the same thing in other cohorts as well. So this is definitely still ongoing. And this concludes the journey of the 10 papers. I guess from here on, from up until here, it's been sort of fairly smooth sailing, simply because I have had no time to go into all the nitty-gritty details lurking just beneath the surface. I'm fairly certain we'll have a chance to go to that in a little while. For now, just before going to the assessment, I want to say thank you. This is now presented as my work, but it's definitely the work of quite many people. Over the last decade, I've had the fortune to collaborate with 449 different co-authors. The 26 of these have put a lot of time and effort into the papers that are now present as my own. In particular, I need to highlight Søren, Jesper, Laura, and David. They have all been co-authors on more than 3 of these papers. Actually, Søren has been a co-author of all 10 of the papers. He's my go-to guy on anything cancer related. And I guess this is on many accounts just as much his thesis as it is mine. So I guess this is now time to say, this is my work. What do you think? Thank you.